Hi, I hope everyone is doing well. In today's video, we are going through compound interest and depreciation. Make sure you have a pen and paper ready to take down some notes and answer some questions. For us to understand how to attempt compound interest questions, we need to know what is meant by interest and we need to know what is meant by compound interest. Interest is money that is paid regularly at a particular percentage. Compound interest is where the amount of interest you get changes each year because you get interest on your interest. So it's basically interest on top of interest. Calculate the interest on saving £80 for 2 years if the compound interest rate is 10% per year. So you put £80 in your bank. Each year it increases by 10%. Let's go through this. Year 1, you have a starting value of £80 plus the 10% at the end. So you'll find 10% of £80, which is obviously £8. £80 plus £8 equals £88. Now at the start of year 2, you'll have £88. So this new value of £88 is what we're going to take over to year 2. We're going to add 10%. We'd find 10% of £88, which is £8.80. As you can see, the amount of interest that we got in year 1 and the amount of interest that we got in year 2 was different. In year 1, we got £8. In year 2 is £8.80. So once you add £88 and £8.80, we get a final value of £96.80. For us to be able to attempt compound interest questions, we need to know something which is called a multiplier. So we can solve compound interest problems using the multiplier method. Say for example, you have a 5% increase. This would be 100% plus the 5% increase. 100% is the original value plus the 5% gives us 105%. If we was to write this as a decimal, to get from this number to a decimal, you have to divide by 100. So 105 divided by 100 is equal to 1.05. This 1.05 is what we will refer to as the multiplier. Here is another example. A 17% increase would be 100% plus 17%, which gives us 117%. To find this as a decimal, we will divide by 100. So 117 divided by 100 equals 1.17. This 1.17 again is what we will refer to as the multiplier. Here is another example. 8% decrease would be 100% minus 8%, which gives us 92%. Again, if we want this as a decimal, we will divide this by 100. 92 divided by 100 equals 0.92. So we can say that the multiplier is 100 plus or minus the interest rate. So we can say it is a plus if the value increases and it will be a minus if it decreases, and you divide it by 100. This is how we work out the multiplier, which we will need to work out compound interest and depreciation. Let's go back to one of the examples we had on the previous slide. Calculate the interest on borrowing £80 for 2 years if the compound interest rate is 10% per year. Now this question can become more difficult if the years was much higher. So if it was 10 years or 15 years, so on and so forth, it will get quite long in terms of writing it down. So we have a formula to work this out. The amount of n years, so the amount after n years is equal to the starting amount times by the multiplier to the power of n. And this n is the number of years. So whatever the number of years is, that is what you do to the multiplier to this power. So let's use this information in the first example and let's see what we get. We want to work out the amount after 2 years. The starting amount was £80. You multiply it by 1.1. And how did we get this 1.1? This was 100 plus 10 divided by 100. So 100 plus 10 is 110. 110 divided by 100 is equal to 1.1. The only thing we're missing is the power, and we're going to do it to the power of 2 because that's how many years we are looking for. Once you put this into a calculator, you get the answer of £96.80, which is the answer above. So we can use this method to work out the amount after n years. Let's go through a few more examples. £1,000 is invested in a bank account that receives 3% compound interest per year. How much will be in the bank account after 4 years? So we can use this formula again to work this out. So the amount after n years equals the starting amount times by the multiplier to the power of n, and this n refers to how many years we are working with. So the amount after 4 years is equal to 1,000, which was the starting amount, times 1.03, which is the multiplier, so that is 100 plus the 3%, which gives us 103, divided it by 100 gives us 1.3 as a multiplier, to the power of 4. Once you put this in your calculator, it gives us an answer of 1125.50881. What you need to understand is that when we are working with money, there can only be 2 numbers after the decimal place. So what we will do is we'll find this to the nearest penny. So we are going to round this 8 up. So the final answer is £1,125.51 to the nearest penny. Here is another example. Jack puts £8,000 in a savings account with an annual compound interest rate of 11%. How much will he have after 3 years? So annual means yearly. So again, we'll use the formula above. The amount after 3 years is equal to 8,000 times 1.11 to the power of 3, which is the amount of years. Again, this answer is to the nearest penny. So he would have £10,941.05. Hopefully we should understand what compound interest is. Now we will work out what is depreciation. We can say that depreciation refers to when the value of something goes down over time. The value of a car usually decreases with time, therefore its value is said to depreciate. So compound interest is when the value of something goes up. Depreciation is when the value of something goes down. A car is valued at £6,500 in 2015. It depreciates every year by 5%. What is the cost of the car after 3 years? So again, we can use the formula from the previous slide. The amount after 3 years is equal to the initial amount, which is 6,500 times 0.95, which is a multiplier, to the power of 3 because we are working for 3 years. Once you put this into your calculator, you get an answer of £5,029.58 to the nearest penny. Always remember to round your answers so that there is only 2 numbers after the decimal place. Here is another example. Lucy bought an antique ring for £200. Its value depreciates by 10% each year. Calculate the value of the ring after 11 years. Again, we use the formula from before. The amount after 11 years is equal to 200, which is the initial amount, times by 0.9, which is a multiplier, to the power of 11. Once you put this into a calculator, it gives you an answer of £62.76 to the nearest penny. Here are a few questions for you to attempt. Please pause the video, have a go, and we'll go through the answers on the next slide. Hopefully you had a chance to attempt these questions. Let's go through them. Luke invests £25,000 for 3 years in a savings account. He gets 2.7% per annum compound interest. Calculate his total bank balance after 3 years. So we're looking for the value after 3 years. We know that the starting value or the starting amount was 25,000 times 1.027, which is the multiplier, to the power of 3 because we're looking for 3 years. Once you put this into a calculator, you get £27,080.17 to the nearest penny. Nick bought a new car for £13,000. Each year the car depreciates in value by 12%. How much will it be worth after 7 years? So we're looking for after 7 years. So we're looking for the value after 7 years. We know that the initial amount was 13,000 times 0.88, which is the multiplier, to the power of 7 because we're looking for 7 years. Once you put this into a calculator, you get £5,312.78 to the nearest penny. Here is a summary of what we have gone through today. We have gone through what interest is. We have gone through what compound interest is. We have gone through what depreciation is. We have found out how to use the multiplier or how to figure out the multiplier. And we have a method to work out the value after n years. I hope you have been able to benefit from today's video. If there was anything you need further explanation on, you can always leave the question in the comments below and I will answer accordingly. Hopefully I'll see everyone safe and sound for the next video, and as always, take care of yourselves.